final definition for me for today, which is called oriented curve. I would like to precisely define what is the meaning of an oriented curve. Okay? So curve is oriented. Curve is oriented if it doesn't changes orientation with its parameterization sign. That's it. So curve is curve C, and whenever you are talking about curve C with okay, maybe I don't need P here. So curve C is oriented. Okay. If all of its parameterizations, are orientation preserving, orientation preserving. So what do you mean by that? You can't find a phi, okay, that is okay, that doesn't satisfy this property. Okay, that's not increased, is strictly increasing. Okay, what would be the more proper way to say it? Orientation, if they are orientation preserving, so all of these phi's are going to be strictly increasing actually. So you can't find a decreasing or maybe a kind of a constant, function phi which kind of take you from one parameterization to another parameterization actually. Okay. Orientation so a reversed curve. So what do you mean by reversed curve? So a reversed curve, okay, is going to be the curve that is the same curve but with the opposite orientation actually. Okay, so with the precisely opposite orientation. So what you have to keep in view, a curve and its reverse are two different things actually. Okay, so the curve and its reverse, we're going to treat them as two different quantities. Okay, so this is an important thing. So in other words, if I'm moving around this, this curve clockwise or anti-clockwise, I'm going to treat these two things as two different things actually. These two motions as different motions. Okay, they will not be too much different in their calculations and rest of the things, but there will be slightly some interesting differences actually in the. Okay. So a reverse curve for a given curve, we denote it by phi bar. Okay. Reverse curve C bar is a curve parameterized. How are you going to find the parameterization of a reverse curve? Parameterized by P bar. Okay, it's going to be a map from, say, I bar to Rn. Okay, so I'll write in a moment that what is the meaning of I bar. So imagine I know what is P and what is C and what is I, okay, for this curve. So the question is, how can I find a reverse curve for a given curve? So what you need to do, we're going to denote it by C bar and the parameterization P bar, and the interval is I bar as this. So the I bar is I bar is simply the collection of the additive inverses of these from the I. So that's one of the things. Okay, it's just simply the collection of the additive inverses. So if your I is 0 to pi, then I bar is going to be minus 2 pi to 0. Minus 2 pi to 0. Okay. You see? The definition tells you that take all points from the I and make the additive inverses. So if I have interval 0 to 2 pi, so what would be its reverse section?
Minus 2 pi.
Okay.
So it may be reflecting, sir.
Huh?
You are reflecting the.
Reflection can take it. You can call it if you wish. How do you define the P bar of the T? How do you define the P bar of the T? So the P bar of the T is defined, or a point on the reverse can be get by take your curve P and substitute what? Take the reverse curve and substitute minus T into it. Okay. So you're gonna say that you have a C bar curve with the parameterization P bar, okay, and define it in this manner. Okay, so you can easily get it. So what would be the parameterization for example, P of T equal to sin T and cos T? So reverse curve for this is going to be क्या होगा? So the P bar of T is going to be minus sin T cos T. Okay? Sorry, sin T. Minus sin T and cos T. Okay? And the T's are coming from where?
Minus 2 pi to 0.
Is it minus 2 pi to 0 or 0 to 2 pi?
0 to 2 pi, because we have changed T is a minus 2.
So if you want to keep minus 2 pi to 0, then you don't need to put a minus here actually. Okay? But if you want to keep, for example, this minus, then you have to change T from the 0 to 2 pi. Okay, so you can get a reverse curve of a given curve. Okay?
Sir?
You can ask a lot of questions. If a curve is, orientation preserving, is it reverse curve is also orientation preserving? Okay, maybe one of the question is that.
सर कर्व का ओरिएंटेड होना सर नहीं मतलब क्या फायदा देता है सर मोशन के अलावा सर मोशन की एग्जांपल में समझ में आ रहा है
You will see some of the benefits of it when you're going to do the line integrals. Will prove some of the very interesting results. Okay, for example, you might have learned, you said that you did some of the things in your physics course. You might have learned if you have a conservative vector field, take a conservative vector field like a gravitational field actually, okay, and compute its line integral actually. Okay, around a closed path. So what would be that? What would be the integral of conservative vector field actually? So it's always zero. The question is how you're going to prove it. Okay. So we'll see that when you are going to prove that the integral of a conservative vector field is zero, this oriented curve will give you a lot of information. We're going to play an interesting role. Okay, so we are defining things for a reason. Obviously, we are not defining things for no reason. We're going to use them often. So what is the bigger picture for today? So we defined what we mean by a regular curve. We defined what was the path. We defined what we mean. So whenever we are talking about the parameterization of a curve, we defined what do we mean by a curve actually. So for a curve, curve is a subset in R3. But that subset in R3, you get it through a parameterization or through a path actually. But that path must satisfy some properties. So if a path is not satisfying those properties, that path may be the path, but it would not be the parameterization of the curve actually. So if it has to be parameterization of curve. It must be path. It must be piecewise, smooth. This must be piecewise regular. Okay, that's what we did. And then the next thing that we did was reparameterization. Actually, we did some definitions of reparameterization and examples, and we ended at the. I have been went very slow. I hope कि थोड़ी बातें आप समझ आई हैं. शायद आगे इतना slow ना. ठीक है? So make sure you are absorbing this basic theory. ठीक है? Because आगे जब हम curve कहेंगे, I'm not gonna get into all these details. I'm gonna say it's a curve. So I'm gonna assume आपको पता है curve के पीछे क्या है. Say about paths and paths satisfy all these properties. ठीक है? So see you next class.
Next Monday.